Hi, and welcome back. In this video, we are going to continue our exploration of the special senses. So we've already learned about taste and about smell. And so now we're going to learn about vision. So let's start with the anatomical structures first. So first of all, the eyeball is in the eye socket, in the orbit, and it's surrounded by fat cushionings to keep it off of the bone, so just above it and below it. There's muscles surrounding it, and there's also going to be your tear glands in there. Outside the orbit, on the skin, we have our eyebrows, which are mostly for facial expression. Some of you can raise one and not raise the other, but I can't do that. Yes, the stuff is falling from directly ahead, and you get the bushy eyebrows, it can catch that. But if it's falling from straight down, it's not likely to go in your eyes anyway. So we do have eyelashes and eyelids, which are super important for closing to keep things out of our eyes. The eyelids also serve the purpose of moistening and protecting the eye, and we'll talk about the moisture in a few moments. Okay, now, if you're really bored and you're studying, there's all these websites you can go to about celebrities without eyebrows, and you can see if you can recognize them, and you realize that we really do rely on eyebrows. And ladies' eyebrows, their shapes, their sizes, they come in and out of vogue about every 10 years. So if your eyebrows, you don't like them now because they're not in style, just wait. They'll be in style later on. All right. Now, on the anterior, the external surface of the eyeball, there is a layer of tissue called the conjunctiva. And so here we have a stratified squamous epithelium, and we're going to have some goblet cells in there. We're going to have lots of blood vessels and the connective tissue deep to the epithelium, and we're going to have some nerves so you can feel if you have something touching your eyeball. And the whole point of these goblet cells is they are going to do what goblet cells normally do. They're going to secrete small amounts of mucousy secretions. And the conjunctiva is the stratified layers with all the blood vessels, covers the entire whites of your eyes, as well as if you look at the picture, you can see it covering the white of the eye, but then it also goes and covers the inside of your eyelids, both your upper eyelid and your lower eyelid, as you can see here. Okay. And so this serves a really important purpose because it's the blood vessels here which are bringing nutrients and oxygens, which are then going to leave these tissues, be secreted, and will actually supply nutrition to the outer layer of the eye, especially the clear part that has no blood vessels. Okay, so the blood vessels, the conjunctiva, they're not covering that clear part of your eye, the pupil, because that would be like looking through here where you would, not have a clear vision. All right. Now, if the conjunctiva gets inflamed, that's called conjunctivitis or pink eye. And I think by now most of it has pink eye, whether it's from rubbing your eyes with allergies or poking yourself in the eye or contagious disease that little kids all give to each other for chlorine swimming pools. Staying on the outside of the eye, we have what's known as the lacrimal apparatus, all the parts that are going to bring you tears. And so the biggest part is the lacrimal gland. So we have several lacrimal glands for each eye, and they're all located here on the upper outer part of the eye socket above the eye. And it's continuously making fluid. And that fluid is bathing, comes out here and is bathing the anterior surface of the eye, and then it kind of works its way towards the medial surface. As you blink your eyeballs, it's moving medially. And then right here, next to this pink part right there on the center of the medial aspect of your eye, which has a name that we're not going to bother learning, there are little openings that the fluid, the tears can drain into, and they collect, and then they will drain through a duct which opens into the nasal cavity area, and that is called the nasolacrimal duct. And from there your tears go into the back of your throat, your pharynx, where you just swallow them. And this kind of explains why if you're crying a lot, whether it's from cutting the onions or watching a sad movie or whatever, or you're laughing so hard you're crying, that you end up having to blow your nose because you have all these extra tears in your nose. and they're not draining posteriorly like the small amount drains. All right. So looking at the anatomy of the eyeball, what we have are 3 layers or tunic. The outermost layer is called the fibrous tunic because it has some tougher tissue in it. And it, when you look at most of the eyeball, is going to be white in color and it's going to be white on the models. The middle layer is called the vascular tunic, and so it usually is pink or pinkish brown or even a light brown color on the models and the drawing. And the inner layer is called the nervous tunic because here's where we're going to be finding all the neurons, so it's usually yellow in color. So looking at the outer fibrous tunic, starting posteriorly, we have the tough white sclera, which stops anteriorly. And remember, this picture is showing it as if it's superior and inferior, when in reality, it's a complete circle because this whole thing is a globe, okay? So you cannot tell, well, I can tell on this picture it's done in, actually done this direction, superior, inferior, in a sagittal plane. So anteriorly, the white sclera ends, and the layer still continues, but it continues as a clear layer known as the cornea, and it bulges out. Do you see how it's bulging more than if you just continued the circle of the sclera? Deep to that, starting posteriorly, we have a very vascular tissue known as the choroid. And as you start coming anteriorly, there's muscle here, and part of it goes in towards the middle of the eye, and that is known as the ciliary body. Okay, so this is the first, or the first set of muscles as you're coming from the posterior direction. So there's going to be 2 sets of muscles. This is the more posterior one. And so we have the ciliary body coming in a whole 360. And from the ciliary body, we then are going to have all these little dense fibrous little bands, which are called suspensory ligaments, and they attach to the entire circumference in one ring around the lens. Going back to the periphery, finding the ciliary body and staying in that same plane and going anterior, the second grouping of muscles is called the iris. And the iris also does not completely go across the eye. It comes in from all directions, but there is a hole in the middle of the iris, and that hole in the middle of the iris is what the pupil is. So all those structures are part of that middle vascular tunic. For the deepest layer, the inner nervous tunic, there are structures we'll learn right now, and we're going to start first with the retina. Now, there are more details to the retina we're going to learn later on, but for right now, we're just going to call it the retina. And in the retina is where we're going to be finding our photoreceptors that we've learned about, as well as other neurons. Okay. And their neurons are actually their axons of their neurons are actually going to be exiting the eyeball in this area right here, which is not when you look straight back, but it's actually off to the side on each eye. It's lateral to looking straight ahead. And that is, it's lateral and a little bit inferior. That's called the optic disc. And so when those axons have exited the eyeball, then they are all called the optic nerve. So this is the origin of the optic nerve. Now, if you were to go straight back through the pupil to the back of the eye, you would run into this area marked by that red circle. So going straight in on each eyeball like this, you run into a little area known as the macula lutea. And we'll talk about its significance later on when we talk about function of the eye. And right in the middle of each macula lutea is a little pit-like depression, not a fossa, nothing shallow. It's like you took your pencil and you poked it in. Okay? And so that fovea, which is a pit-like depression, is right in the center of your eyeball as you go back. So that is called the fovea centralis. So those are the structures of the eyeball. So let's look at the iris a little bit more. Okay, and if you recall, the iris was the more anterior muscles of the middle vascular tunic. So the iris, when you're looking from the outside of your eyeball, is the part of your eyeball that has color from the outside. It's pigmented. So it could be red or gray or green or brown or whatever color you want to be. And on the inside surface, there's actually melanocytes in there so that what's going in is not going to be popping back out. And that's the view we're used to seeing all the time. And although we say somebody has blue eyes, I think you can see from this picture, it's not like a solid blue, like a contact lens looks like. Okay. And if you were to angle so that you could see it, this is not an electron microscope. This is a regular microphotograph, but taken from an angle, you can see that the muscles have a certain amount of depth, and that black part right there in the center, that's the pupil. And so all of this is showing the thickness of the iris. All right, so I said the iris was muscle. So let's talk about how it works and the importance of that. So the pupillary reflex, the pupil diameter getting smaller and getting bigger, happens because of the muscles of the iris. So when we look at the iris, and the pupil here in the middle, the blue part's the pupil. Surrounding the pupil, we have a narrow muscle that goes around the opening, goes around the circumference of the opening. So it's an inner circular muscle. And then outside that muscle, we have a muscle that goes out like the sun's rays. So it's called an outer radial muscle. So either of these muscles can contract, okay? So, whoops, sorry. When you are looking far away, more than 20 feet, going across the room, what happens is those outer radial muscles contract. So they were like this and they were longer. So when they contract, they are pulling the pupil on all directions. So they are dilating the pupil, okay? And that's what happens in low light. Now, when you're in bright light, that doesn't affect those outer radial muscles. That affects that inner circular muscle, and that inner circular muscle contracts. So as you can see, if I can hold my hands the right direction, as you can see, when it contracts, the pupil gets smaller, okay? So bright light, pupil contraction or constriction or getting smaller, that's all parasympathetic effect. That's your third cranial nerve, the ocular motor nerve, okay? Low light, when the radial muscles are contracting, making the pupil get bigger, that's your sympathetic effect, pupil dilation. Okay, so looking at some other structures that are there in the middle layer. Okay, so let's talk first about what the lens is. So the lens basically is a bunch of cells that don't have any organelles anymore. And what they're done, and what has happened is it's been replaced with a protein called crystalline. Okay. And all that crystalline is inside, and now all we have is dense fibrous connective tissue surrounding it with some elastic fibers. Okay. And so now we have this oval structure, and attached to the periphery of it, we have suspensory ligaments, okay, that can pull on it or that can relax. Okay. So can you understand it? By having elastic tissue in there, and it gets pulled on or relaxed, that can change the diameter of that lens. So let's start first with far vision again. With far vision, what happens is the muscle over here relaxes, and that pulls the ciliary body away so that the tension on the ligaments increases. So now it's getting pulled all these ways so that the lens diameter has to increase. And the way the diameter is going to increase is that it's going to go from this, it's going to flatten out with a bigger diameter. And that's how our eyes are most of the time, because most of the time we're dealing with far vision, not near vision. That when we're reading, we're studying, that's all near vision. But when you're hanging out with your friends, walking around, that's almost all far vision. So what happens with near vision When the muscle contracts, the ciliary muscle contracts, that allows the suspensory ligaments to slack. And so now we're going to go from that resting position with the wide diameter, and we're going to narrow the diameter, but now have the lens get very fat, very thick or bulgy, spherical in shape. Okay, let's talk about some more structures. So this is a cross section through a human eye, and let me just orient you. Here is the upper eyelid, there's the lower eyelid, and this is the optic nerve out back. This oval structure, hopefully by now you have recognized as the lens, and so just anterior to the lens, this would be the iris coming in from each side. This would be the cornea, and here's parts of the ciliary body going in from each side as well. So all of the area from ciliary body to suspensory ligaments to lens to suspensory ligaments to ciliary body, everything anterior to that is filled with a fluid known as aqueous humor. However, we divide that into two different areas. Between the posterior border being the ciliary body, suspensory ligaments, and lens. So right here, just draw a line right through here where the left side of the blue is. And then the next line you're going to draw is to go from the iris through the pupil to picking up the iris on the other side. So if you're anywhere between those first two lines that we just drew, that's called the posterior chamber. And if you are anterior to the iris, so in other words, between the iris and the cornea, that's called the anterior chamber. So both the anterior chamber and the posterior chamber are filled with aqueous humor. And as the name implies, aqueous meaning watery, this is a very thin, watery liquid. And it basically is a filtrate that comes from blood, so it's bringing nourishment with it. And that nourishment is going to go to the lens, which doesn't have blood vessels, and it's going to go to the cornea, which doesn't have blood vessels. And this turns over every hour and a half. By the time you're done with everything for today's talk, for a regular class, all your aqueous humor would have changed over. It comes from blood, goes back into your blood. Now, posterior to the suspensory ligaments, ciliary body, lens line, that very first line we drew, everything posterior to that is going to be the vitreous chamber, and it's filled with what's called vitreous humor. And this looks nothing like aqueous humor. This is very gelatinous. So if you've ever made Jell-O, it's kind of in that phase where it's not liquid yet, but it's not set yet. So it's gelatinous, it's super thick, it's starting to mold, but it's not quite there yet. And what this does, this gelatinous fluid, is it provides a certain amount of pressure inside the eyeball, so intraocular pressure, inside the eyeball pressure, which maintains the shape of your eyeball. Now this is formed in utero and it's never replaced, okay? So you can get floaters through this as debris collects over your 120 years of your life. If you would have a penetrating wound to the eye and the vitreous humor goes out, there is a synthetic substance we can put in there, but nature's always best. Okay, with that, I'm going to stop this first part, which was just anatomy, and then we will pick up with more topics in the next video. And I thank you for all your hard work, and I will see you again shortly.